moment of inertia of uniform triangular plate about axis passing through sides AB, AC, BC are IP, IB, IH respectively. Okay, so now about AB, the moment of inertia is IP, and about AC, the moment of inertia is IB, and about this it is IH. Okay, basically this is P means perpendicular, B means base, and H means hypotenuse. Okay, and passing through point C, there is one axis passing through point C like this, perpendicular to the plane. Then that is IC. Okay, and then we have to find out the relation between them. How will you do that? Now let's compare first this one, IP, IB, IH. Okay, if we see IP and IB, okay, the farthest mass is at 4, right, at a distance 4 for IP. So obviously IP is greater than IB. That is for certain. IP is greater than IB because most of the mass is further in the case of IP compared to IB. See, the furthest mass is at a 3, but for IP furthest mass is at a 4. Okay, so that is true. So IP is greater than IP. Now let's look about IH. Okay, let's find out IH. How will you do for IH? So let's say we have this point as our center of mass. This is a center of mass for this one. Okay. We don't need center of mass basically. Let's do like this. We don't need. Let's find out this distance. This is the farthest distance, right? So this farthest distance, because this is a hypotenuse, this is 3. So this must be less than 3. Okay, so the farthest distance is less than 3. Now the 3 distance was for IB, right? IB. So that means this must be less than IP. Okay, IH must be less than IB. So that means IB is greater than IH. IB is greater than IH. Okay. Okay, so PBH is done. Now what about IC? How will you know if the moment of inertia of IC is greater than IP, IB or less than IP, IB? How will you find out that? So let's look at that. Suppose we have the axis like this passing through this. Okay. But before that, let's find out what is the moment of inertia through this axis. Let's say this is IA axis. Okay, IA dash axis, because okay, IA axis we can say. This is IA axis. Now, about IA axis, I can find out moment of inertia using parallel axis, perpendicular axis theorem, because IA is equal to IB plus IP, which are perpendicular to each other, and IA is perpendicular to this plane. No? So IA is equal to IP plus IB. Okay, IA is equal to IP plus IB. Okay, now to find out the moment of inertia about this axis, okay, we can use parallel axis theorem if we know the moment of inertia of COM, moment of inertia of COM. Let's say this distance is y, this distance is y, this distance is y, this is y distance, this is x distance, this is y, this is x distance. Now if we know this moment of inertia about center of mass, then what will be it? ICOM. We don't know, it is ICOM. So IC can be written as ICOM plus, this is ICOM, no? ICOM plus my square, plus my square. Basically IC is ICOM plus my square. Now IA will be how much? ICOM plus mx square. IA will be ICOM plus mx square. Okay. Now we can put this value of IA in this. We want to find out IC, no? So we can put IC is equal to ICOM can be put from here. IA minus mx square. IA minus mx square plus my square. This is IC. but IA is IP plus IB. IP plus IB plus M times Y square minus X square. This is IC. So you can see clearly IC is nothing but addition of IP and IB. Okay, and y square minus x square, okay, plus m y square minus x square. Okay, now see y is greater than x, right? So that is a positive number. So IC is greater than IP plus IB, addition of P and B. So that means IC must be greater than both of these individually, na? So this means IC is greater than IP. So this is the correct relation. IC is greater than IP is greater than IB greater than IH.